So, you're interested in DecarbonICE? Well, this short video will explain what DecarbonICE actually is and how it can help us achieve our climate goals. Watch this. Well, we have a problem on this earth. See, this is a factory emitting a lot of stuff. CO2. There's also a few okay substances amongst it. There's a lot of CO2. Emission. We have too much of this. This is our problem. If we're not going to use this as our daily gear, we're going to do something about this. So how do we do this? Well, the good news is actually there's plenty of technologies to take out the CO2 from emissions. So you can take out all the bad stuff and all the clean air goes up. Take out all the bad stuff. So what to do with all this CO2 that we captured? Well, there's actually another good story. I'll show you. The good story is, on our planet, where we've actually been pulling out a lot of fossil fuels, well, the same planet is actually also a fantastic reservoir for storing CO2. There are plenty of sites both onshore and offshore. It's easy. We can capture the CO2 and we have plenty of places to store. So, what's the problem? Well, part of it is, of course, that some of these technologies are not that mature yet. But there's a big push in order to mature the capture technologies and the storage sites. So we have capture, we have storage. The only missing link is the transport. So what do we do? Well, one solution is that we can put the CO2 into these pipelines. We can take the CO2 from its gaseous form, make it liquid, and put it into pipelines. So these pipelines just need to be put somewhere. And remember this? Well, the problem is that people are also using this ground for farmland, for recreation, a little bit of wildlife. So where to put all these pipes? Well, it's a long and tedious process, but we need to capture this CO2 in a very short time. No doubt there will be put a lot of pipelines, but probably not enough if we want to achieve our goals in not heating up the planet too much. Remember that swimwear before? So we need other solutions to complement all the pipelines. So, any good ideas? Well, before we answer this question completely, we just need to look a little bit into the chemistry of CO2. What you see here is a phase diagram. And CO2, like water, can exist in several different phases. Water, we have ice when it's freezing. We have it as water, typically between 0 to 100 degrees. And then you have water as steam. Well, CO2 is more or less similar in that sense. It can exist in a solid form. We call that dry ice. Maybe you know that from experiments in your chemistry class. We have CO2 as liquid form. That's when it needs to run into pipelines. And then we have CO2 in gaseous form. That's typically the way we capture CO2 from emissions from a smokestack. In addition, there's something called supercritical form, but we save that for a little later. Well, when you have captured the CO2 as gas, you capture it, and then sometimes, depending on the technology you use, you make it into liquid. Then you can transport it pipeline, or maybe also in we call an ISO container, or on a liquid CO2 carrier, a ship. But in addition to that, we can also convert the CO2 into dry ice. We can use something called a dry ice machine. Or if we capture the CO2 in a cryogenic process, it's actually already captured as dry ice. So we want to transport CO2. Remember, we have a load of emissions that needs to be taken from A, the emitter, to B, the storage site. And transporting the CO2 in its gaseous form doesn't really make sense. takes up a lot of space. We need to compress it somehow. We could do that in a liquid form and put it into pipelines, for example. That could in some cases make sense, but remember then we need to put down all these pipelines. We could also transport it as dry ice. That's what we're going to look into. So we take the CO2 from its gaseous form and into dry ice. Then we have CO2 in its solid form. And why is that a good idea? Well, let me explain. First of all, as you see in the diagram, is that CO2, in order to be liquid, it needs to be higher than 5.11 bar at atmospheric pressure. So basically, CO2 cannot exist in its liquid form under atmospheric pressure. That push a lot of requirements to the construction of pipelines or tanks for the CO2 because it needs to withhold this pressure. In addition, the CO2 in its liquid form needs to be very, very clean in order to fulfill contamination standards, in order not to make problems. But you also have the dry ice. CO2 can exist as dry ice under atmospheric pressure. The only thing you need to have is a cold enough temperature. So it just needs to be below minus 78.5 degrees. Then it exists as dry ice. And then you can transport it under atmospheric pressure. That makes a lot of sense from a safety perspective. And that also takes down a lot of the complexity of having requirements for very clean CO2 and pressure vessels and so on. So that actually means that as long as you can handle it in its very cold form, for example in small pellets, then you can safely transport it. And if you have an accident, a container is dropped somewhere, you don't have CO2 spreading out all over, running out, and basically removing all the air so you can't breathe. No, it just stays there and very, very slowly will evaporate into gaseous form. So transporting CO2 in the solid form is a very good option to work in parallel with, for example, transporting CO2 in pipelines. Let's look at how we can do that. Well, remember the CO2 from before that we captured? We just need to convert this into dry ice. And what we do then is we take a handful of standard shipping containers, standard basic shipping containers, 20-foot containers. We insulate them, we convert the CO2 into dry ice, boom. And then we have CO2 in solid form inside these containers. Totally standard. Something that we know already. We can stack them on container ships, we can put them on trucks in an existing logistics chain. So let's look at how we do this. We have a truck. We take the container with CO2 inside, we put it on the truck. Whoop. Maybe we have a hanger, so we put more CO2 containers on the truck. We transport it from the emitter side. Vroom. We have a small container ship. What do? An existing container ship. We take the CO2 in the standard 20-foot containers, load them on this standard container ship. There are thousands of these already, ensuring world trade today. And we load them and we transport them to the place where we want to store our CO2. Sounds simple. Now we just need a place to store our CO2. And remember, there are plenty of places to store CO2 in this world. So there are plenty of places to help us clean up the mess we did historically. We have a storage site. We have our containers. There's somebody here helping us to store all the CO2 in the storage site. This goes down depending on the geological formation of the specific storage site. If it's sandstone or if it's volcanic ashes, then it needs to go down maybe 200-300 meters down, or maybe 1.5 kilometers down, all depending on the geology. And there, CO2 is stored safely and permanently forever. And we have helped clean up this mess. Now the only thing to do is reduce those emissions so we don't need to store more than we actually need. But that's something you need to work on. This was a story about DecarbonICE. Are you interested in learning more? Then visit decarbonice.org and follow our project and our innovative developments, and help us bring safe, scalable CO2 transport to the world.